So for this I don't write benz 1 comma 2 dioic acid. This is not the naming pattern in the case of benzene. In the case of benzene, we follow dicarboxylic, right? Dicarboxylic naming pattern. Can be written as this. Any problem? Now you tell me that I have told you NH2 and CH3 combination on benzene is toluidine. So what will be its name? Its name will be O-toluidine, right? What will be this? This relation is meta, so it will be M-toluidine, right? This relation is NH2 and CH3 at para, so it is P-toluidine. These are the names of this compound, okay? Next is your section of carboxylic acid. So now, what is the name for this compound? You know that this is known with the name of benzoic acid, right? It is also known as benzene carboxylic acid. So both the things are one and same. It is benzene carboxylic acid. Now the thing which I want to tell you, that the combination of COOH and CH3 on benzene is what? It is known with toluic acid. So how will it look like? Suppose this is your benzene and here COOH is there and here CH3 is there. So this is ortho relation. So what will be the name? The name will be O-toluic acid. Now it's your homework to draw the structure of meta-toluic acid and para-toluic acid. Okay, this you have to do. The next thing is, this is the compound given to you. First of all, you tell me that what are the functional groups here. So there is COOH and there is OH. Two functional groups are there. Carboxylic is what it is? It is highest in the priority list. So what will be the name? The name will be 2-hydroxy benzoic acid. That will be its IUPAC name. If I ask you the common name, so you have to remember that is SALICIC, that is salicylic acid. Now I am going to give you the name of dicarboxylic substitution on benzene. Now here you will not write the IUPAC names as carboxy benzoic acid. No, this will not be the thing. You will not do like if this is 1, you give it as 2. It is 1, it is 3. So some of you can think that we will write 4 carboxy benzoic acid. No, that will be wrong. So what will be the name? The name will consist of both the carboxylic at the same time at the same position. So for this I don't write benz 1 comma 2 dioic acid. This is not the naming pattern in the case of benzene. In the case of benzene we follow dicarboxylic, right? Dicarboxylic naming pattern. So here what will be the name? The name will be benzene 1 comma 2 dicarboxylic acid. Similarly, in the next it will be benzene 1,3 dicarboxylic acid. In the next structure again, it will be benzene 1,4 dicarboxylic acid. What are the special names for these? So the very first is PHALIC, that is phthalic acid. Second is isophthalic acid. The third one is terephthalate acid. Okay. Next, we will discuss about acid derivatives. So first of all, in acid derivatives, we have a structure. In the place of OH, I will write Cl. In the second, in the place of C double bond, then OH, I am going to write NH2. Right? In the third question, in the place of C double bond OH, I am going to write O, CH3. Right? In the next example, I am going to write O, C double bond O, CH3. Now some of you, what you think that this and this both are the same. No, these structures are not the same. On the one hand, benzene has been attached to C double bond O. In the second case, benzene has been attached to the oxygen. So these two things are really very different, and it's a star mark for you. Right? So discussing for the very first question, it will be either benzoyl chloride, it will be benzoyl chloride, or it will be benzene carbonyl chloride. Discussing for the second, that is C double bond O NH2, that is amide. So either we will write benzamide, that is the naming pattern of amide, or what we can do, if we want to write benzene as it is and then we want to add something, then we will write benzene carboxamide. Now comes these two special structures. So the very first thing is this: these both structures, that is C double bond O and O, are the functional group, that is ester, right? But the thing is this, here after the O, that is alkoxy part, is what? Methoxy. And here after the O, I know that only this functional group has been flipped, but a lot of changes arises. Here this will be treated as a substituent because it is attached as an alkoxy part. So here the alkoxy is methoxy, but here the alkoxy is not methyl. It is what? It is phenyl. Okay? So let me explain it. So here it is ester, okay, and the naming pattern of ester is alkyl alkanoate, right? Here the alkyl part is CH3 because it is attached to the oxygen, that is methyl. So here methyl is there. Here after the oxygen, benzene has been attached, so it is alkyl part, right? And here it will be called as phenyl. Fine. Here for the remaining naming, it is benzene carboxylate. So I will write methyl benzene carboxylate, or I can write benzoate, whatever you want. So if I write benzoate or benzene carboxylate, both are the same things. I am write benzoate only here. If I talk about here, it is C double bond O CH3. So what it will become? It will become ethanoate. that is this structure. Next, let's discuss some more. What is the functional group here? First of all, you tell me. It is substituted amide. How I am saying substituted amide? Because here it is not NH2, it is just only NH. So it is secondary, right? Now how will you name it? First of all, at the end phenyl is there. So I will write it as N-phenyl. And here 2 carbon chain is there. So I will write ethane amide. That will be the name of my compound, right? Next, here suppose if I again flip the functional group, I added C double bond here and then I wrote CH3 with NH. Now what will happen? The alkyl group is now CH3 because anything which is attached to nitrogen becomes the alkyl group. So this is again a question mark. Again this is a star mark question for you. So you will write N-methyl. Right? You will write N-methyl and rest as benzenamide or benzaamide. Okay?
Classes, these gaps go unnoticed. With one-to-one mentoring, chemistry becomes logical and real improvement begins.